Hello, class 11th physics, kinematics. In kinematics, we are going to study about motion in a straight line and motion in a plane. And in kinematics, we don't study the cause of the motion. So, force, energy, these terms are not going to be covered in kinematics. We are going to study them later on in Newton's law of motion and other chapters. So, in order to start the discussion, let me tell you about state of rest and state of motion. And for that, we require an object, the motion of which we are going to study. But most importantly, we require a reference point with respect to which motion is being observed. So the point is called reference point with respect to which motion is observed. So if we are observing motion in a straight line, then there is only one axis, either horizontal axis or vertical axis. But it is just the one dimension only. And in this one dimension, from which point are we measuring or are we observing the motion? That point can be here, that point can be here, or that point can be here. Depending upon the situations, the point can be anywhere on that axis. Same here, we can observe it from here, somewhere here, or from here. This is the motion in one dimension, and that point will be called reference point. Then there is frame of reference. Frame of reference, if we talk about relativity and relativistic mechanics, then it is a little bit complicated, but what we are going to study here is Newtonian mechanics, so that will be little bit simpler. So frame of reference is the set of coordinates and a reference point. Well, now nowadays for frame of reference, a clock is also considered to cover the entire system of frame of reference. But here uh, for class 11th, we are just limit ourselves to this set of coordinate and reference point. That reference point generally uh, lies at origin, but it can be anywhere depending upon the question, depending upon the problem, depending upon the situation. Okay, so one more thing, this in this kinematics, we will uh, comprehensively use calculus. That is a new kind of mathematics. What is it? I will tell you side by side as we move on in this chapter. Okay, so let's start with the very basic discussion of distance and displacement. Distance symbol is S, displacement again symbol is S. Now what is the difference? It is a scalar quantity and it's a vector quantity. What are vector and scalar? For that I will make a separate video. We can say that such physical quantities in which we don't direction to be specify that physical quantity. Whereas displacement type of quantities where we need uh, the information of direction also. So direction is not only the criteria, there are some criteria also, but we will discuss about it later on. But here this symbol is in some books differentiate both of them by putting an arrow over it, but here in kinematics we are not going to use their vector form. This is their vector form. So we are going to use symbol S only. So what will happen if we have to consider, we have to find distance and displacement both in the same question? Then what will we do? Then I suggest that at that time write displacement by arrow and mod, but that condition or simply write displacement there, so there will be no confusion. SI unit for distance is meter, SI unit for displacement is also meter, dimension for distance is L, dimension of displacement is also L. But what is the distance? Distance is simply the length of the path, but this is the half of the story. We are interested in the distance traveled by an object. So distance is the length of the path traveled by an object. No matter what is the shape of the path, whether it is a straight line, whether it is a zigzag line, this is a path, or whether it is a curved line. And how are we going to measure distance? We are going to measure distance using a meter tape. So we can easily measure it, no matter whether it is a straight path, whether it is a zigzag path, or whether it is a curved path. We are going to measure it using a meter scale or meter tape. So distance is length of the path traveled by a body. So if body travels this and then comes back, so length of the path will be this plus this. It is not just only limited to the path, but the length of the path traveled by the object. So displacement depends upon two endpoints, from where motion has been started and where motion has been ended. So if this is starting point, we will call it initial position, and it is ending point, we will call it uh, final position or terminal position. So displacement is the straight line with an arrow. Arrow is indicating in which direction displacement has taken place. So it means if I draw this diagram again in a backward direction, it doesn't mean that both are same. Both are magnitude wise same, but direction wise they are different. So we are not going to say that both are equal. Sometimes say that if motion is taking place in a straight line, then distance and displacement both are same. Uh, it is conditionally correct, otherwise it is incorrect statement, incomplete statement actually. If motion takes place in one direction, in a straight line in one direction, then distance is equal to mod of displacement. We have to take its numeric value only, because displacement can be negative, positive, even zero, but distance can be uh, positive only. It can be zero if body is not moving, but for a moving object distance must be positive only. So we can't say that for a straight line path distance is equal to displacement. And here also I have said one thing, that straight line path in one direction only, because in straight path this can also be happen. If it is returning back, in that case distance can never be equal to displacement. So be careful about using these terms just by some ordinary explanations. Go into the depth of it. All right, so moving on. Okay, one more outcome from entire this discussion, that distance generally is greater than or equal to displacement. Mod. Okay, to avoid any confusion, we can say it like this. Uh, what will happen if that we take it negative? Still distance will be greater than, yeah, but it can't be equal in that case if we are taking it negative. So we have to put that mod sign. That is important. So distance divided by displacement is always greater than or equal to 1. We know displacement with mod. We know it is generally greater than this distance, generally greater than displacement, and in one case it is equal to mod of displacement, not just displacement. Okay, moving on. Then there comes speed and velocity. Before explaining speed and velocity, let's divide them into two categories. First, average speed, and instantaneous speed. Similarly, average velocity and instantaneous velocity. Now, what is average velocity? Average velocity is the overall velocity. For complete motion or for uh, greater interval of time. Same for average velocity. For greater interval of time or for complete motion. instantaneous speed and instantaneous velocity. These two. These two are quite new terms. Actually, in class 9th, you have already studied it. But now they are going to be bit complicated. But before, okay, average speed. Average speed is not like that adding all the speeds and divided by number of speeds. It's not like that. Average speed is, okay, just the symbol for speed is v, symbol for velocity is also v. So be careful about these symbols. Its SI unit is meter. It's meter per second. It is better to write it in this way, meter per second. And dimension LT minus 1, here also LT minus 1. Okay, so average speed is VAV, or you can use this much scientific notation, angular bracket. So both means average is equal to total distance upon total time. Similarly, here average velocity is, this time it will be net displacement upon total time. Okay, so next is instantaneous speed, instantaneous velocity. So if while traveling through a bus or car, if you have ever noticed the speedometer, then speedometer shows instantaneous speed. So instantaneous means at that instant, speed at that instant. So instantaneous speed is equal to instantaneous distance traveled divided by time instant. Whereas instantaneous velocity is also same, instantaneous displacement divided by time instant. Now what does it mean? Actually, if I want to find speed at a particular moment, then I will call it instantaneous speed. Or velocity at a particular moment, then we'll call it instantaneous velocity. So how is it different from average speed or average velocity? So if we are interested to find average speed or average velocity, we are considering entire motion or bigger fraction of the motion. Like here, like in our daily life, if I have to go to market and I will see that market is this much kilometer far, and if I have to go there fast, I will try to achieve more speed. So this is how we use this concept in our daily life. At that time, what I am doing, I am dealing with average speed. What about average velocity? It is also quite similar to that. If I have to approach somewhere, and no matter which way I am going, but if I have to approach somewhere, so am I approaching that target uh, in a proper time? So in that case, we consider the case of uh, velocity. By the way, there is a confusion among students. They think that if motion is one dimensional, motion uh, body is going in a straight line, then it will cover displacement, and then velocity will be found. Velocity will be obtained. And if it is going in a curved path or irregular manner, then we find distance, and we deal with the speed. That's totally wrong. Actually, if we are going in a straight path, still we can find distance as well as displacement. And if we are going in a curved path or a zigzag path or in any other irregular path, still we can measure distance and displacement. Just recall their definition once again. I am not explaining it right now. uh, just rewind this video and see how I have defined distance and displacement. Okay, so I will just do a little more discussion about instantaneous distance and instantaneous speed. Uh, so here what we used to do, as I told here, we take a bigger portion of the motion, but for a particular moment, if I have dropped this styler and I want its speed or velocity at particular moment, somewhere here, let us suppose somewhere here. So how how am I going to measure that speed? Or sometime in the question it is given that a body starts its motion with velocity so and so. At that time, its velocity was uh, that was instantaneous velocity at that point. If I throw it up, this styler, if I throw it up, then you can see at the top it stops for a small fraction of time. At that time its velocity is zero, its speed is zero, but that is for a smaller fraction of time, for that instant only. So at the top, instantaneously its speed or its velocity is zero. So that is instantaneous speed or velocity. So at that particular moment, what is its speed, what is its velocity, that will be instantaneous speed or instantaneous velocity. Now, how are we going to show this? So generally we write it like this: delta S by delta T. Right now, I'm okay. It looks like change in position, change in displacement upon change in time. Well, it is half true. It is actually a fraction, a smaller portion of displacement and that smaller portion of time interval. If we draw a distance time graph here, and if this is the graph, then a smaller portion, for a small instant I am taking a smaller portion of it, this much small. So for that smaller portion, we take this value is delta S and this value is delta T. Then this delta term comes. So that is why it is not like a change of displacement. No, it is that smaller fraction from that graph. Same here. Okay, now I'm going to explain you something which looks little bit unusual, and uh, I'll be more into instantaneous velocity. I'm interested in instantaneous velocity. It is because in most of the question you are going to uh, deal with the question in which instantaneous velocity is asked. Okay, now see, let us suppose, again I am drawing a graph. This is S, this is T, and I am taking a small portion here. These are two values of displacements and their difference will be delta S. There are two values of time and their difference is delta T. So there will be delta S by delta T, and this is how we are going to find instantaneous velocity at that particular instant. If we reduce this time interval, see, if it is greater, if it is appreciably greater, then that will be average speed or average velocity. But if it is smaller and smaller, then we can give a precise value of instantaneous velocity. So remember, if delta t is large, then the discussion will go for average speed or average velocity. But if delta t is small, now how much small? So again, let us consider another type of motion in which yeah, I hope ah, this much thickness will be observed. Okay, now let us suppose this is S, this is T, and motion was something like this, quite irregular. If it is slant, it is easier to find velocity at any point. But now it is changing at different points. In fact, let me draw it with a thin line, which I believe will be visible on camera. So I have drawn it something like this. I could make it more complicated than this, but I'm interested in something else which I'm going to show. Now see, if I want to find velocities, let us suppose this is displacement time graph. So I'm interested to find velocities for this region. So you can see at this region, we can see there is a variation. Slope is changing, displacement is changing, and it is not changing in that manner, in a regular manner. It is changing. Okay. Now we can find average velocity. That's not a big deal. But we know it is not the exact value because speed has changed, velocity has changed. You can see here it was faster, then it became slower, slower. So in order to find velocity at a smaller region of it, that will be instantaneous velocity. Let us suppose I am interested to find velocity at this instant, at this time. At this time, let us suppose it is uh, at 10 second. 10th second, what was its velocity? So at 10th second, it's difficult to find its velocity. What I have to do, I have to take a smaller region. Exact at 10 second, I can't do anything. I have to take little bit, I have to go little bit forward, I have to go little bit backward. Maybe I have to go for 10.1, 9.9 to 10.1. And in between those time interval, whatever be the displacement. So I have to take a small portion. But if we see, if I magnify it, still it is not a straight line. It has a slight curve in it. So I can reduce it further. I can take the interval at 9.01, sorry, uh, 9.99 to 10.01, and so on and so forth. I can reduce it further and further and further and further. So I can do it, I can magnify it again and again and again and again. And let us suppose I take this much smaller portion of it, maybe hundredth of thousandth times smaller portion. And if I restore it back to its original value, it's quite difficult to identify it. What I want to explain here is, for v instantaneous, at that particular instant, if I want to find this value of velocity, then this delta t must be very small. How much small, later on I will tell you, but keep this thing in your mind. If that time interval delta t is quite large, then we are measuring average velocity. And if it is very small, if it is very large, then average velocity. If it is very small, then instantaneous velocity. And if it is vanishingly small, then we are measuring correct value of instantaneous velocity. If we are able to reduce it to vanishingly small value, vanishingly small, in which delta t tends to 0, then we are exactly measuring. I mean, exactly is again subjective term, but yeah, of course, we are too close to find instantaneous velocity. If delta t tends to 0. But in our ordinary mathematics, if we put something that much small number in the denominator, then entire fraction will tends to infinity, which is not accepted answer, because we know body had some non-zero, some finite value of velocity at that point. But ordinary mathematics is showing delta t tends to 0. This problem came into the mind of Newton, and he developed a new kind of mathematics. I'm not explaining you how it comes, because you are going to study it in mathematics in class 12th. So I am just summarizing some of the formulae which are used in such situation, and what are we going to use next. I'm just going to explain that only. So in such situation, we don't use this ordinary mathematics in which we divide the things, but what we do, we replace. If, see, v instantaneous is equal to delta s by delta t, and if delta t tends to 0, then we can write it like this: limit delta t tends to 0, delta s by delta t is equal to ds by dt. Is it a meaningless term? Are we just playing with the symbols? No. Delta s by delta t means there is delta s, a numeric value, there is delta t, numeric value, and we are dividing both. But limit delta t tends to 0, delta s by delta t means t is approaching 0. It is vanishingly small. And now we are not using that ordinary division. We are using this thing, which is called differentiation of s with respect to t. Actually, what is differentiation? It is the measurement of variation of one variable with respect to other variable. How much s is changing with a change in time. Graphically, it is called slope, and we know in class 10th we have already studied it. If there is displacement time graph, there is any graph line for a particular motion, we find its slope, and that us velocity. Same thing is here. S and this base, which is delta t. So this is also, differentiation is also showing us the slope of the graph. It has some limitation, but it is, it can work for these curved, zigzag, and graph, different kind of curves at that. Now there are some, actually there is a long list of rules of differentiation, but I'm for the time being, I'm just telling you only those rules which I'm going to use in this video. So uh, later on, as we go into the depth of this topic, I will be explaining you um, the other rules. Okay, now first thing, if we want to find v instantaneous, now I am not putting instantaneous again and again. If we are using this differentiation, then what is this s? This s is not just a numeric value. This s will either be a constant c, let us suppose some number, means s is a fixed number. It is not changing with time. Think which situation is this. Or it is changing upon time with this relation, s is equal to t to the power n. And now don't think how s is equal to t. Maybe there are some constants involved in it, and that constant is 1. So ultimately units will be taken care of, or it is equal to some constant multiplied by t to the power n. So there are basically 3 cases. Otherwise there are several cases, but basically I am taking only these 3 cases. Then this formula can be uh, velocity sorry velocity is equal to d, in the place of s there is some constant, by dt. So this is very easy formula. This is 0. Differentiation of a constant, pure constant, is 0. What does it mean? Let me show you this thing graphically. S is not changing. Initially S has this value and it is not changing. See, this is the case for uh, stationary position of slope. So differentiation works. Next, if S is equal to t to the power n, t to the power n by dt, then remember this formula. N is taken outside and t to the power n minus 1. How is it so? There is a proper derivative this rule also, but it's not in the scope of our physics. We have been gifted these formula by mathematics and we are taking it. But if you still want, I will give its derivation in some other video. Now, v equal to d c t to the power n by dt. We'll take this constant. If constant is alone, then it will become 0, but it is with t to the power n twice, and it is simply that ordinary formula we know very well. So it becomes cn t to the power n minus 1. Let me give you some example for these. Let us suppose uh, the question is, I will give you this and this because they explain about it, or should I give? Yes, I am giving some example for this also. Velocity of a moving object, of an object, of an object sorry, velocity, not velocity, position. Position of an object mm, varying with time as follows. First one, S is equal to, or sometimes they can give, in the place of S they can give X. Still the thing is same. It also shows distance or displacement. It is showing along x-axis. 5 t to the power 0. I have purposely given it in such a manner. And let us suppose all the values are given in SI unit. Second question, x is equal to t to the power 5, and c x is equal to some constant 5. I have chosen it purposely, t square. Now in this case, actually it is not depending upon time, it's it's a constant. So if we want to find v, that will be dx by dt. uh, as the matter of fact, what we can do, so that you could not find anything undigestible, so I'm writing it y and I'm writing it z, so that you will be so sure that okay, these values can be given in terms of s, in terms of x, in terms of y, in terms of z. All of them are showing their position, their displacements. So here it will be d5 by dt. It's a constant, it is just a number, so velocity is 0. Next, if you want to give a try, you can try yourself, pause the video, give a try. Okay, I'm explaining it. dy by dt, ultimately dt to the power 5 by dt, and which is 5t to the power 4 in SI unit. Here also v equal to dz by dt and d 5t square by dt. So it is 5 multiplied 2t, which is 10t. Most of the time we are going to use such type of expression will come, so that will also be important. Okay, so this is a new kind of mathematics. Be careful about it. And it doesn't mean that with this new kind of mathematics we will forget our old type of mathematics that will also come. So I'm taking a question for on the basis on the topic of average velocity. So let us suppose there is a relation x equal to 5t square minus 3t. In SI unit, of course, I am not mentioning it to avoid some extra symbols. So, okay, whenever you see such type of expression in which t and such kind of variables have been given, and then you are asked to find velocity, that's for sure you have to differentiate it. But in this question, what I am asking you, find average velocity for the time period between no, it's not making a sense. Between the time period, between the time period t equal to 3 second to t equal to 6 second. Okay, so if average velocity, remember, as I told you, average velocity, a bigger time scale will be there. instantaneous at that particular moment. See, this is the difference. So here there is a time range of 3 to 6. How are we going to find average velocity? So here we don't need to do differentiation. What we will do, we will find x at t equal to 3, we'll put t equal to 3. And now I can put meter. And then again x at t equal to 6 second, then it will be 5 multiply 6 square minus 3 multiply 6, 180 it is, 18, 162 meter. Then we have to find displacement delta x. That will be this minus that. It will be 126, I guess. 126 meter. Yeah. And delta t 3 second. From 3 second to 6 seconds. So 6 minus 3, that is 3. So average velocity will be displacement divided by time. Remember, for average velocity or average speed, what you need to do, you have to find some numerical values, and then you will end up with such type of numeric values, and you are going to divide something. Ordinary mathematics will be used for average velocity. So remember this thing. And in the same question, they can also ask, find velocity at particular time. And they can ask, if the same question is asked to find um, velocity at 3 second, if in the same question they ask find velocity in 3 second, find velocity at t equal to 3 second, when object at t equal to 3 second, what is the velocity of that object at this instant only, at this 3 second instant only? Then we have to do the differentiation. Now simply it will be, bracket will be off. So differentiation is also not a difficult thing. It follows certain mathematical operations, but it has its own formula. So here 5 and t square, remember that formula, d by dt t to the power n and t to the power n minus 1. So n t to the power n minus 1. Here also people will say that it will be 3 dt by dt, and dt by dt it will be cancelled. Yes, of course, but it will be cancelled in other manner. T to the power 1, 1 will come in front, then t to the power 1 minus 1, then 3 into 1 t to the power 0, then it is 1, and hence it is 3. So this one and minus 3. So it will be 10t minus 3. Sorry. but they have asked us to find it at t equal to 3. Now we will at t equal to 3, in fact at any time, we can find just by replacing 10 multiplied by 3 minus 3 at this particular moment. Its velocity is 27 meter per second. So same thing you can also do for other time interval, for 4th second, for 5th second, for 6th second, or any time interval. In fact, at 2.1 second, or whatever be the time instant you choose, that will be much accurate. So that's all in this video. In next video we'll do some more problem based question.